We're going to close out this set of topics by talking about geometric sums, and in particular, finding a closed formula for a geometric sum. We're going to follow the same format as we did for arithmetic sums. We're first going to do an example, then we're going to use that reasoning and strategies that we did in the example to find a general formula. So here's the geometric sequence that we're going to be looking at for our example. 3, 12, 48, 144. So we start with 3. Every time we go from one term to the next, we multiply by 4. So we're going to find a formula, again, for S8, much like we did for the arithmetic sums. And that starts at A0, that's 3. And then the last term is going to be A8, which is 3 times 4 to the 8. And as noted before, note that A0 is equal to 3. That's why we have 9 terms instead of 8. So the strategy for geometric sums is a little bit different from the arithmetic sums. Remember, with the arithmetic sums, we just wrote the terms in reverse and everything worked out. That does not work out for geometric sums. So what we're going to do is see what happens when we multiply our sum by 4. And an interesting thing happens, right? When we multiply that first term by 4, we get 3 times 4. When we multiply the second term, 3 times 4 by 4, we get 3 times 4 squared. The third term goes from 3 times 4 squared to 3 times 4 cubed. And we just sort of keep on going. Notice that everything is going to look exactly the same as the original. There's just going to be one extra factor of 4 in there. Now, the nice thing about having almost all the terms be the same is that when we subtract them, lots of cancellation goes on. So if I subtract the left-hand sides of those equations, we get 4 times S8 minus plain old S8. But for the other ones, on the top is our 4 times S8, and on the bottom is our minus S8. And notice that, again, that all of the terms, or almost all the terms, are the same, except they're negative. So you have a 3 times 4 on top, a negative 3 times 4 on bottom. 3 times 4 squared on top, negative 3 times 4 squared on the bottom. So a lot of the terms on the top are going to get canceled by the ones on the bottom. The only ones that survive, well, let me see. So 4 S8 minus S8 gives me 3 times S8. The only ones that survive are the highest power one in the positive side, 3 times 4 to the 9th, and then the lowest power of 4 on the negative side, that's going to be minus 3. And then we divide both sides by 3 and get S8 equals 3 times 4 to the 9th minus 3 all over 3. So now all we're going to do is just generalize this strategy to a general geometric sum. So our geometric sequence that we're going to get the sum from, we start with some number a, and then we multiply by our number r each time. So if we go from a to ar squared to ar cubed, etc. So if I want to know what Sn is, I'm going to add up all the terms starting at a, which is my initial term, all the way to a times r to the n. And then to get the terms to be mostly the same, I'm going to multiply both sides of that equation by r. And as before, there's going to be one more factor of r in each term. Now I'm going to take r times Sn and subtract Sn. On the left-hand side, that's what you get. On the right-hand side, you get, well, there's the plus r times Sn, and there's the minus Sn. So if I take the left-hand side and factor out an Sn, we get r minus 1 times Sn. Those right-hand side of the equation, there's going to be a lot of cancellation. As before, everything cancels except for 2 terms. There's going to be that a times r to the n plus 1 that survives, and then on the top, and then on the bottom, that minus a that survives as well. And now we can divide both sides by r minus 1 to get Sn equals a times r to the n plus 1 minus a all over r minus 1. All right, so now I think you're ready to finish up all the activities on the PDF included with this video. Again, it's called More Arithmetic and Geometric Sums.